Hi, Professor. This is Shuo. I'm going to talk about my sixth assignment. So for the problem part, uh, I'm going to talk about the table 2.7, which is the relationship of height and the weight of human beings. So the x value is the height of the human beings, and the y value is the weight of the human beings in this table. So in the subproblem 6.3.1, we're going to use the basic linear model to predict the weight as a function of height. So the model formulation looks like just a basic linear model. So and then I applied the normal equation to calculate the coefficient of A and B. So here is the result. We get A is 5.13 and B is minus 178. So the linear model of weight as a function of the height looks like this. And then I calculated the error sum of squares, SSE. So first I calculate the deviation of the actual y value in the data, subtracted by the predicted value calculated from the model for each x value, and then I take the square of the deviation and take the sum of the deviation of square, and then we get the value of the SSE. And next, I calculated the SST, which is the total corrected sum of squares, which we use the difference of the actual value and the mean value of the predicted value from the model, and then we take the square of the difference, and then take the sum of the square of the difference, and we got the result. And then we calculated the regression sum of squares, which is the subtraction of SST and SSE. And the last one is we calculated the coefficient of determination, which is the square of R. We use 1 minus SSE divided by SST. So we got the result. So all the result is shows in this table. Then I make the residual plot, which the x-axis is the x value in the table, and the y value, the y-axis is the residues, which is the deviation of the actual value from the table and the predicted value from our model. So from this plotting, we can see that the residues is this point. They are randomly distributed and located in a small band, which is from minus 1.5 to 2.5. And the model to be accurate, because we don't see a linear trade in the plot. So for the next subproblem, we're going to use the basic linear model to predict the weight as a function of the cube of the height. So the difference is for this problem with the previous one is here we use the cube of the height. So first, we got the transform the data of the cube of the x value, and then same as the previous problem, I use the normal equation to calculate the coefficient of A and B. So here is the model we calculated, and then I apply the same process as previous problem to calculate its SSE and SST, SSR, and R square, and then the final result shows in the table. And then I plot the residual plot. So from this residual plot, we can see that the residues distributed as curvilinear. So the refinement of this model, of the second model, which is the weight is proportion to cube of the height, needs refinement as required. So this is the problem in assignment 6.